Now that we've seen what logarithms are, let's look at how they behave and look at the properties of logarithms. The first property I'll go over, I think you already know, is that for any base b, the log base b of 1 is going to be 0. Recall that b to the 0 power is always 1. So, of course, that follows, going backwards, the log using base b to get 1, the exponent, the log, is 0. The second property is that for any b, any base b, the log using base b of b to the x is x. Now sometimes that's so easy it's hard. That's like saying, who's buried in Grant's tomb?
What would you do with a brain if you had one?
Or what is Elvis's first name? Or when was the War of 1812? You see how this is so easy it's almost hard. It's like saying, what is the exponent of b to the x using a base of b? Well, of course, it's x. Now, why is that important? This second property here. Well, this is going to allow us to solve an equation like this one. Looks difficult, but in the future, what we're going to do, we're going to introduce a new tool taking the log of both sides. And if we take the log of this, think about it on the left side, the log base 2 of 2 to the x is x. That's going to allow us to solve some very difficult equations. Now that x will equal the log base 2 of 7, whatever that is. And we'll figure that out. We'll work with that later. So I hope you see that second property is going to be quite useful. That the log base b of b to the x simplifies to x. Look familiar? Okay, let's move on to the other properties. Basically, this is going to be divided into 3 properties, and this is the one you're going to use way more often. Since logarithms are exponents, remember the rule of exponents? When you multiply expressions that contain exponents, you add the exponents. Well, guess what? Logarithms are exponents, so when you multiply an expression that contains a log, you add the logs. Another property of logarithms, since logarithms are exponents, is that when you divide expressions with exponents, you subtract the exponents, don't you? Guess what? When you divide expressions with logarithms, you subtract the logarithms. And finally, when we have one more property of logarithms, since logarithms are exponents, when you exponent an exponent, we end up multiplying them, don't we? Well, when you exponent a logarithm, you end up multiplying them. Look at the other place where you can put the b, and this is going to be the most useful of all the properties, because that b is hard to get when it's up in the exponent. Another place to put it is down in front, and we can solve an equation much easier, get rid of the b if you would, when it's down on the ground. Okay, so that's another location we can put it.
Pay attention, boys. I'll show you how it's done.
Let's use the properties of logarithms to expand this problem. We'll start with, we have an expression here with division. A logarithm with division becomes a subtraction of the logs. Division becomes, and notice that it becomes an easier operation. This is good. This is a good trend. Now what else do we have in here? We have multiplication of not exponents, but multiplication of logarithms. And, of course, it's the same rule. To take the log of two numbers multiplied, we'll add the numbers. Now, what about the third rule? Where else can we put these exponents? The exponent rule tells us that we can multiply, once again, the next easier operation. And actually, and this isn't a rule of logs, if you think about it, 3 log of a's is log of a plus log of a plus log of a, isn't it? We can bring that one down, and minus 2 log of c's is, so actually, we can take a very complicated calculation and turn it into a bunch of pluses and minuses. And this is going to be very important eventually, because that is the way your computer and your calculator work. It uses logarithms to change these very difficult problems with exponents and division and multiplication into a bunch of pluses and minuses, or ons and offs. And that is a fact. An expansion like this may be interesting, but for the most part, we're going to be using the properties of logarithms to condense a problem. We're going to work backwards and contract these into one giant logarithm. Where can I put this 2? Remember where else I'm allowed to put it. And what about the 3? He can become an exponent. And what does addition become if we work backwards? Summing the logs means multiply. And basically, if you think about it, 3 squared times 2 to the third is 9 times 8. We've made this into one big fat logarithm.
What a dumb thing to do.
Well, you're going to want to do it in the future to solve equations. Believe me. This is called a contraction. Okay?
Do that again.
Let's do another one. I work with the exponent first. So a number out front can move to that exponent spot and back and forth. Now, remember what we do with subtraction. Subtraction becomes division. And we've made this into one big fat logarithm. It's important for you to note that 1 log is going to be our goal.
Well, Poindexter, what do we do now?
What does this contract to? Don't let it scare you. The log of c plus the log of a plus the log of b plus the log of I plus the log of n. This is a classic mathematical problem. Remember what addition becomes? Multiplication. So this long expression actually becomes, well, log cabin.
Almost had a gag, son. Joke, that is.
Sorry about that. Okay, let's do another. I want you to get good at contracting, making them into one big fat logarithm. Addition is going to become multiplication, 25 times 3. And subtraction is going to become division. We could write it as a fraction. And 75 divided by 5 is 15. So the answer here is the log of 15. Remember, we want to make it into one log. Eventually, you'll see why when we go to do equations. How about this one? Well, let's see. Let's work on our exponents first. I say you don't see any exponents, but there will be. Where can I put that 2? Now I have another number out front. Don't let him scare you. He goes up in the exponent position, and we know we can have half as an exponent. Now this one's going to go up in the exponent position for the whole expression inside of parentheses. Now all we're going to have to do...
Excuse me, Professor Brainiac.
Oh, what is x to the 1/2? Let's write that in simpler terms. X to the 1/2
I'm dangerous. I'm very, very dangerous.
is the square root of x, isn't it? So you could write it that way as well. Remember, that's a rule of exponents. Now, addition... Oh, quit crying. Addition becomes multiplication, and subtraction becomes division. And you have changed this into one big logarithm.
Brilliance. That's all I can say. Sheer, unadulterated brilliance.
Won't get any harder than that. Okay, well, I want you to go practice these properties, especially the contractions into one logarithm, because we'll be using that in the next show.